So now let's talk about the problem of the day. During this time, we'll think together about how to represent and solve this problem and what it teaches us about math. When I ask you questions, please make sure to answer out loud, just like you would in school. So last year, one of my students represented like this. They drew a triangle, and they labeled it 3 toothpicks, because they knew each triangle uses 3 toothpicks. Then they put 21 total underneath, because they knew from the story that Arnold has 21 toothpicks. Then they put a question mark, and they labeled it how many triangles, because we don't know how many triangles we can make. Another student that I had represented like this. They wrote a number sentence. They put K, and they labeled it triangles, because we don't know how many triangles Arnold can make. They wrote 3, and labeled it 3 toothpicks in each, because we know there are 3 toothpicks in each triangle. And then they wrote equals 21. They labeled it the total, because we know that Arnold had 21 total toothpicks. So my question is, what do both of these representations show? Say it out loud. Yeah, they show that there are 21 total toothpicks and that each triangle will use 3 toothpicks. But we don't know how many triangles we can make. So your representation might look like one of these, or it might look a little different, but do check to make sure it shows the same things from the story that these representations do. Okay, so what are we trying to solve here? Say it out loud. Yeah, we're trying to figure out if we can make triangles with 3 toothpicks each, and in doing so, use up exactly 21 toothpicks. So I'm going to keep track of how we might solve this problem and what we're learning today on this visual anchor. So how can we solve this problem? Say it out loud. So some of you probably said that we could draw the triangles and skip count by 3s. So let's try that. Count with me as I draw. 3, 6, 9, 12, 15, 18, 21. So, can we use all 21 toothpicks when we make triangles? Say it out loud. Yeah, we totally can. But I bet some of you solved this in a different way. I bet that some of you knew we could use all the toothpicks to make triangles before we drew this picture. How could you know that we could use all 21 toothpicks to make triangles without a picture? Say it out loud. You might have said that you knew 7 groups of 3 is 21, or thought 3 times 7 is 21. Some of you definitely remember that 21 is a multiple of 3, because we can multiply a number times 3 and get 21. So I'm going to record this number sentence on our visual anchor. So 7 groups times 3 in each equals 21 total. Cool. So let's use this to help define a new vocabulary word. And that vocabulary word is factor. Factors are numbers you multiply together to get a product. Read this with me. Get ready? Go. Factors are numbers you multiply together to get a product. Think about that definition and the work we just did. What are the factors of 21 that we just found? How do you know? Say it out loud. You might have said that 3 and 7 are factors of 21 because we can multiply 7 times 3 to get 21. 7 groups of 3 is 21. I'm going to add that to my visual anchor here so we remember. 7 and 3 are factors of 21. Great. Okay. Now, if we were trying to find the factors of a number, what could we ask ourselves? Say it out loud. Right. We could ask, what numbers can I multiply to get this product? Okay, let's try that with 21. Ask yourself, what numbers could we multiply to get 21? Say it out loud. Yes, 3 and 7, but what else? Say it out loud. 1 and 21. 1 times 21 is 21. So, 1 and 21 are also factors of 21. Go ahead and click the arrow and move to the next slide.